All right, so we're going to do more triangle proof examples. I have two more examples, so I'm going to pick up on number 3. And again, I already wrote this out just to save some time. So if you will pause your video so you can get that written down and then you can continue. Okay, so on this one, we are looking to prove that triangle EGH, which is this one right here, is congruent to triangle FGH, which is this one right here. So we're trying to prove that these two triangles are congruent to each other. All right, now here's our given information. We know that GH bisects angle EGF, and then we know that EG is congruent to FG. And then we have our proof statement. So we need to figure out the 3 things that can prove that these two triangles are congruent to each other. So first up, let's mark that GH bisects this angle. Well, bisect means to cut in half. So this segment cuts this angle in half. That's what that statement says right there. So this segment right here cuts that angle right there in half. So what that tells me is that this angle is going to be congruent to that angle. All right. Then the other thing we're also given is that EG is congruent to FG. So EG is congruent to FG. Now we need to look at, because that's 2, we need a third item, and always we have, a segment that's used in both triangles, so we can use reflexive property for this one, and then we know using side angle side that those two triangles are congruent. All right, so here it goes. So we have statements and reasons, and we are going to number them. Now, this one, unfortunately, wow, look at how straight that is. This one, unfortunately, is going to take more than 4 steps, and I will explain that in just a second. So 1, 2, 3, 4, 5. Okay, so first thing we want to do is write what we're given. So GH bisects angle EGF. So that was given. So GH bisects angle EGF. That was given information. Okay. Now, that doesn't tell us that those two angles are congruent. It just tells it that this segment right here cuts this angle in half. So what we need to do now is say that those two are congruent. Sorry about that. So now we're going to say angle EGH. EGH is this one right here, EGH. So angle EGH is congruent to angle FGH, is this one on this side, to FGH. Now, the reason is that that is the definition of bisector, or definition of bisect. So if something bisects something else, it cuts it into 2 equal pieces. So when this segment cut this angle in half, it cut it into 2 equal or congruent pieces. Okay, so that gives us our angle up here. Now, we want to finish with our given information. We were told that EG is congruent to FG, and that again was given information. So EG and FG are congruent. We said ourselves that GH is congruent to GH, and anytime we mention that a piece is congruent to itself, that is reflexive property. All right, so now we've taken care of the angle, and then the side, and then the side, which is not in that order. Oops. But using side, angle, side is the correct order. We have proven that those two triangles are congruent. So triangle EGH is congruent to triangle FGH. All right, perfect. So that one required 5 steps because when this statement said that GH bisects that doesn't tell us that the two angles are congruent. All right, one more example. And again, for time, I went ahead and drew it out already. So if you want to pause the video so you can get it copied down and then pick up when you're ready. All right, so on this one, we are trying to prove that RST, which is this triangle right there, is congruent to this triangle down here. All right, now SQ and PR bisect each other. Okay, so here we go with that bisect again. So SQ and PR cut each other in half. All right, so what that means is that when PR crosses SQ, it cuts SQ into 2 equal pieces. And then when SQ crosses PR, it cuts that into 2 equal pieces. Now, they're not necessarily equal to each other. It didn't say that SQ and PR were congruent. But that does give me 2 sides of this triangle with 2 sides of that triangle. So now we need something else. And we know from Math 8 that this angle and this angle are vertical angles, and vertical angles are always congruent. So there we go. There's our 3 things. So we have side, angle, side again. All right, so this one is also going to take more than our 4 lines. So statements and reasons. All right, so let's see. All right, I'm going to stop right there for space. Okay, so first thing we want to do is put our given. So SQ and PR bisect each other. What? I just fit it. All right, and that was given information. Okay, now, because of that, we know that ST is congruent to QT, and that is definition of, abbreviating there, of bisect, or bisecting, or bisector, whatever. Bisector, maybe we'll say that. All right, so since they bisect each other, we know that ST is congruent to QT. Another thing that we know is that PT is congruent to RT. So PT is congruent to RT. And that, again, is definition of bisector. All right. Now, that gives us our 2 sides. We said that since vertical angles are congruent, which is our reason, so vertical angles are congruent, we know that this angle is congruent to that one. Well, this angle up here, we'll call it STR. So angle STR is congruent to this angle down here, which STR would match up with QTP. QTP. And that's because vertical angles are congruent. So now we have our side there. There's our second side, and then there's the angle in between. So this is actually side, angle, side. These aren't in the right order, but that's not a problem. All right, so now I'm just going to copy over my statement here. So triangle RST is congruent with triangle PQT, and the reason is side, angle, side. All right, so that gives you 2 more examples on writing 2-column proofs to prove triangles are congruent.